Skateboard ramps and water slides. Y'all remember. Some y'all don't remember. A culture starts with 20 bacteria and triples every hour. Write a formula for the number n of bacteria after t hours. Exponential functions are all y equals a times b to the power of x. A is our starting amount in this problem. That's 20. B is our growth rate. In this problem, it triples, so it's going to be times 3 to the power of x, or in this case, the power of t. So there's our equation. Nice and easy. 20 times 3 to the power of t, that is b. Number 2, Kyle saved $500 from a summer job. He spends 10% of his remaining savings each week. How much will Kyle have after 15 weeks? Again, we need a times b to the power of x. A is the starting amount, $500. B is the growth rate. The problem with this is they give us a 10% growth rate. Well, actually, he's spending 10%, so it's our decay rate. If we have a percent, we've got to remember, take 100%, either add or subtract 10. If it's increasing or growing, we're going to add. Here he's spending, so he's losing 10%, which is 90%. That means he keeps 90% of his paycheck or his savings every week. So our growth rate here is going to be 90, move the decimal point over 0.9. To the power of x, x here is 15 weeks, so the power of 15. 500 times 0.9 to the power of 15, that's a calculator question. 500 times 0.9 to the power of 15. We got $102.95. Which is F. So that was number 2, F. Number 3, the number of subscribers to a web service is growing exponentially. If there were 100,000 subscribers initially and it grows by 2.4% per month, how many subscribers are there after a year? So a times b to the power of x, our starting amount, 100,000. Our growth rate, 2.4%. It is growing by 2.4%. So take 100 plus 2.4, you get 102.4. That is our growth rate. We have to convert that to a decimal, though. Take the decimal point, move it 2 places, you get 1.024. To the power of x, how many times is it happening? A year. We're looking at each month, though. It grows per month, so a year is 12 months. 100,000 times 1.024 to the power of 12. We got 100,000 times 1.024 to the power of 12. And they have 132,923 subscribers. 120. Oh, we got to write it down. I was going to look for multiple choice. 132,923. 132,923. There's our number of subscribers. Number 4, the domain of the exponential function 14 times 0.8 to the power of x. You have to know what the graph looks like in order to find the domain. You know what it looks like? Great. Graph it. If you don't, go to your calculator and graph it there. 14 times 0.8 to the power of x. I'm going to graph it. 14 times 0.8 to the power of x. And it looks like this. I can't see much of that, but if I zoom out, menu 4, 4, I see that it looks like this. Now, it's kind of hard to tell, but this graph keeps going up and over forever. It It looks like it kind of stops, but it's going to keep going to the left very slightly forever. So if I wanted to graph it a little bit exaggerated, I could make it look like this. That keeps going that way, and that keeps going that way. Domain is left to right. Left, well, I also know it's not y. I'm going to eliminate that. To the left, it keeps going, and there is no boundary over here. It just keeps going forever that way. To the right, it keeps going forever that way. So we have no left and right boundaries, which is all real numbers. Just to make sure, choice C, x is greater than or equal to 0, that tells me it stops right here and goes greater than 0. Well, this graph clearly doesn't because it goes to the left into quadrant 2. D says x is greater than or equal to 14. Well, 14 is way over here somewhere. They're just throwing that in there because there's 14 is a problem, thinking you might choose it. It is all real numbers. Number 5, they give us a graph of caffeine from a drink. Your body is processing this caffeine X hours after you drink it. I can tell from this equation that it starts with 160 milligrams of caffeine, and the growth rate is 0.89. That means my body is able to process out 11%. Because that 100 minus 11 is where they got 8.89. The question asks, though, what is the maximum amount of caffeine? Well, it's in the problem, the starting amount, 160. If we didn't remember that, though, we can look at the graph. My y-axis is right here. The starting amount, I don't care about negative hours ago. So this part I can ignore. This is what I care about right there. The starting amount, 160. And from there, it goes down. Number 6. The graph of this function. What is the equation of the horizontal asymptote? Horizontal asymptote is where this graph approaches and never actually touches. So it's like the wall. If you continuously walk halfway to the wall. This graph gets closer and closer and closer to the x-axis, but it never touches it. So what's the equation of the x-axis? Well, it's not that or that. It's either going to be x equals 0 or y equals 0. If you don't know, go to your calculator and graph it. I need to know what the x-axis looks like, so I'm going to try x equals 0. Erase my previous problem. Erase my equal sign. I want a relation. X equals 0. And we get the y-axis when I graph that. It's not the y-axis. It's not going to be x equals 0. If I look at y equals 0, it does give me the red x-axis there. So my answer is y equals 0. Hopefully we know that without having to go to our calculator. We know that x equals 0 is an up and down line. Y equals 0 is 0 slope is a horizontal line. So G, y equals 0 is our horizontal asymptote right there. Number 7, country's population is 1.6 million. That's my starting amount. And each year it is 0.8% lower than the previous year. So that's our growth rate, 0.8. So we take 100. We're subtracting because it's getting lower by 0.8%. 100 minus 0.8 is 99.2. So my growth rate here is 0.992 to the power of x or t or whatever letter. I get 0.992, remember, because we have to move our decimal point over 2 places to convert it back from a percent to a decimal. This means the population keeps 99.2% of the people. The country keeps 99.2% of its population each year. Looks like A is our correct answer. problem and we added 0.08 or 0.8, that's where this answer, D, comes from, 1.008. If we converted or didn't convert the decimal right, if I just looked at that like 8%, that's what's going on here. And then that's just throwing out a 0.8 to try to trick you because that's the number they give you. So it's got to be A. You have to remember to add or subtract the percent to 100 to get your answer. 8. We have a couple different ways we can work this problem. They're giving us a table. We got to find the equation. I can see my starting point, my starting amount. Whatever this is showing me, it starts at 150. My growth rate, how is this growing? Going up or is it going down, and by how much? Well, it looks like it's going up by times 3. Remember, we're not looking at what we're adding. Adding is a linear equation. Exponential is what we multiply. What do I multiply 150 times to get 450? Well, it's times 3. What about 450 to 1350? Times 3. Times 3 there. So it looks like it's growing by times 3 to the power of x. That's looking like choice F. Plan B to work this problem, if you didn't know any of that, is to use your calculator. We haven't worked a scatter plot problem in a little bit, so I'm going to work that one here on my calculator. I'm going to go to a new document, lists and spreadsheets. I got my x value there, and my y value there. And we type them in. 0, 1, 2, 3 for my x value. 150, 450, 1350, and 40. 150, 450, 1350, and 4050. Make sure you push enter after your last number. Add a new page. We want data and statistics this time to make a scatter plot. You have to click on the X to make it your x-axis. Click on the Y to make it your y-axis, and we see this curve, this skateboard ramp going on here. To get the equation, I need to menu, analyze, number 4, regression, number 6, and what kind of graph do we have? We've used quite a few of these throughout the year. We've done linear, that's a line. I know this one is not a line. We've done quadratic, that's for parabolas. I know this is not quadratic. This is 8, an exponential function here. So go to 8, and it gives you your equation right there. 150 times 3 to the power of x, which is what we had, choice F. Number 9, last question. The range of the function 72 times 0.92 to the power of x. Similar to the question above where we did domain, I need to know what the graph looks like. Starts at 72. You could always go to your calculator for this too. My growth rate, 0.92. Is it going up or is it going down? Growing or decaying? That is below 1, so it's going to be shrinking. It's going to look like this. So it might be a little more. It might go faster or slower. I'm not sure how it's going to shrink, but it really doesn't matter if we're looking for the range, because I just need to know where the boundaries are, bottom to top. How low down does this graph go? Well, I know I'm going to have a horizontal asymptote right here, so it's not going to pass 0. How high is it going to go? Well, it keeps going forever and ever. So my y values are everything bigger than 0. 72 is where it starts out. It goes above and below 72. So I can't have A or B. The only real options to look at, y is greater than 0 or y is less than 0. Well, it's not less than, because that's down here in the negative. It is greater than 0. Now, why is it not equal to 0? Why is it not equal to under there? If y equals 0, that would mean it actually finally reaches this x-axis, which it doesn't. That's the asymptote. It approaches it, but never actually gets there. So it's just greater than 0, not equal to 0. And there we have it. That's the end of your STAAR review. Good luck.